Recall that an algebraic fraction is just a fraction with unknowns or variables on the top and bottom that represent normal numbers. Therefore, you could apply math operations like addition, subtraction, multiplication, division on these algebraic fractions in the same way, in the exact same way as you would do with normal fractions. Let's try and add a over c plus b times d, written as bd over c. Now these are two fractions. The common denominator, as you see over here, is c. Therefore, we add them with c as the common denominator, and on the top we add the numerators a plus bd. Similarly, if you were to do the subtraction 2m over n minus m minus 1 over n, you would take the common denominator, which is n, and subtract the numerators 2m minus m minus 1, which is the same as 2m minus m plus 1. Remember, the negative sign distributes over n, and that's equal to 2m minus m is m plus 1 on the top over n on the bottom. But then how would you add, let's say, a over b plus c over d? The denominators this time are not the same. So you need to find the LCM, or the least common multiple of the denominators. But the problem here is you don't know what numbers are represented by b and d. So you cannot find the LCM, but you can certainly go ahead and find a common multiple of b and d, which is b times d. Therefore, you want to make the two denominators the same, b times d. So you multiply this with d and this with d, and you multiply this with b and this with b. And there you go, you have the common denominators. So let's write down the common denominator, b times d or bd. And on the top we have ad, or a times d, plus cb, or let's write it as bc, b times c. So this is how you combine the two fractions. Let's now say you want to subtract, do the subtraction, x minus 1 over x plus 2 minus x plus 3 over x minus 5. Now the two denominators, x plus 2 and x minus 5, are not the same. So we are going to apply the same technique. We don't know what x is, therefore we cannot find the LCM, of the least common multiple between these two. But we can certainly go ahead and find a common multiple between them, which is the product of these two. So you want to rewrite this expression, or this fraction, as x minus 1 over x plus 2. Let me make the fraction bar a little longer, because I'll need to write another factor, times x minus 5, which is the other factor, and multiply the top with x minus 5 as well. So you're not changing the fraction overall. This part is equal to 1. Minus, and do something similar on the other side, x plus 3 on the top, x minus 5 on the bottom, which is given, multiplied with x plus 2 on the top and on the bottom. So now we have a common denominator. So everything on the top over x plus 2 on the bottom times x minus 5 on the bottom. Let's multiply these two out. FOIL, first, outer, inner and last. X times x is x squared. Outers, negative 5 times x is minus 5x. Inners, negative 1x, or simply minus x. And last, negative 1 times negative 5 is positive 5. Minus, remember there's a minus sign here, so you want to use a parenthesis, because the sign of everything in this product each of the terms is going to change because of this minus outside. We have x times x, which is x squared, plus 2 times x plus 2x, plus 3 times x plus 3x, plus 3 times 2, which is 6. And we could actually combine these two. Let's go ahead and do that actually. 2x plus 3x is 5x. So let's have one single 5x over there. Okay. Now let's open up the parentheses. So we have x squared minus 5x minus x. That's this portion. Oh, actually we could combine the minus 5x and the minus x to get a minus 6x. So let's write that down. So we have x squared minus 6x plus 5 minus x squared minus 5x minus positive 6 or minus 6 over x plus 2 times x minus 5. Time for us to cancel x squared minus x squared, so that's 0. So that simplifies to, you have negative 6x minus 5x, that's negative 11x, and positive 5 minus 6 is minus 1. So we have negative 11x minus 1 on the top, x plus 2 times x minus 5 on the bottom. If you want to, you can take the negative sign out and write 11x plus 1 on the top over x plus 2 times x minus 5 on the bottom. And how do you do multiplication and division with algebraic fractions? In the same way as you would do with normal fractions, that is, simplify or cross off common factors from the numerator and the denominator before you go on to multiply the factors out. Let's say you want to multiply two algebraic fractions, something times something, and on this one we have x squared plus 3x on the top, and on the bottom we have x squared plus 4x plus 3 to be multiplied with x squared minus 2x minus 3 on the top and x squared minus 9 on the bottom. Your first job is to completely factorize, if you can, each one of these expressions. So let's start with this one. X is the common factor between these two terms, so let's take that out. X times x plus 3. On the bottom, we have a trinomial. That's an expression having 3 terms. You may or may not be able to factorize it. Let's try it. It's going to be x squared. So you want to think of two numbers that add up to positive 4 and that multiply to give you positive 3. And the obvious choice is positive 3 and positive 1. So you have positive 3x plus 1x or x plus 3. To be multiplied with, on the top, we have again a trinomial. So let's try and factorize it. X squared, two numbers that add up to negative 2 that multiply to give negative 3. So you could rewrite that as negative 3x plus x. That's negative 2x. And negative 3 times positive 1 is negative 3. Minus 3 over, now x squared minus 9. Now you could think of this as a squared minus b squared. You know that a squared minus b squared is equal to a plus b times a minus b, right? So we have x squared, so x is our a, minus 9, which is 3 squared, so 3 is our b. So let's rewrite this as a plus b, which is x plus 3, times a minus b, which is x minus 3. So we have x times x plus 3, and then on the bottom you factorize them in pairs. You know how to do that. X times x plus 3 plus 1, the common factor between these two is 1, times x plus 3. Remember, if you cannot figure out a common factor, 1 is always a common factor. Multiplied with x squared minus 3x, that's x times x minus 3. Again a plus 1 because the common factor between x and negative 3 is 1 times x minus 3 over x plus 3 times x minus 3. And this is going to be equal to x times x plus 3 over, factorize this, means take this common factor out, x plus 3 times x plus 1 to be multiplied with, common factor is x minus 3, take it out, times x plus 1 over x plus 3 times x minus 3. Now if you look, all the expressions are completely factorized. It's time for us to cross off common factors. We see a x plus 3 here and another x plus 3 here, cross them off. We see a x plus 1 here, another x plus 1 over here, cross them off, and x minus 3 goes with x minus 3. Anything else doesn't look like. Therefore, we are only left with x on the top. Everything else has crossed off, meaning they have become a 1, and x times 1 is the same as x, over x plus 3 on the bottom times 1, which is x plus 3. So this is the simplified form of this product. And how do you divide two algebraic fractions? Well, pretty much the same way. Just keep in mind that as you do with normal fractions, you want to flip over the numerator and the denominator on the second fraction in the division sentence, that's all. So if you want to do, let's say 3b squared plus b minus 14 over 2b squared minus b minus 6 to be divided with, let's say 6b squared plus 5b minus 21 over 4b squared minus 9. Your first job is to flip this over. Get this on the top and get this on the bottom and change the division to a multiplication, right? That's what you do with normal fractions. And then factorize each one of these expressions if you can. So this is going to be equal to 3b squared plus b minus 14 on the top over 2b squared minus b minus 6 on the bottom multiplied with 4b squared minus 9 on the top and 6b squared plus 5b minus 21 on the bottom, which is equal to, in their factored forms, 3b plus 7 times b minus 2, that's this, the factored form of this is this, over this one is 2b plus 3 times b minus 2 multiplied with the factored form of this one. This is in the form of a square minus b square. So that's a plus b times a minus b, where a is 2b because a square is 4b square and b is 3 because b square is 9. So we have a plus b, 2b plus 3 times a minus b, which is 2b minus 3, over the factored form of this one is 3b plus 7 times 2b minus 3. Time for us to simplify or cross off common factors between the numerators and the denominators. I see a b minus 2 here and a b minus 2 here, a 2b minus 3 here, a 2b minus 3 here. a 3b plus 7 here, a 3b plus 7 here, and a 2b plus 3 here and a 2b plus 3 here. Would you believe that? Everything has been crossed off or cancelled, which means this big algebraic expression, this division of two algebraic fractions, is actually equal to 1. In other words, this one is exactly the same as this one in their simplified forms. So that was fun, wasn't it? Okay, let's catch up in another video.